Now that Maven is installed, let's understand the first thing that we will do with a Maven configured in our system. What I do as the first thing is MVN archetype generate. So what I am trying to do here is I want to generate a project structure for a standard archetype. So when I say archetype here, you can understand it as a standard project structure. Just imagine your company is having a Java J2EE Spring based project. So if you use that Spring based J2EE archetype in your system, you will conveniently get a source code structure. Along with it a pom.xml, which will actually help you out in automatically building that application. So archetype primarily can be understood as a template which Maven can understand, and it goes to the public repositories and fetch all the required dependencies and set that project and that project's build approach, everything in your system. That is why archetype is very important. If you say I want archetype for a simple Java project, Maven will understand it. Maven will fetch all the basic dependencies which are required for building a Java project. It will set up the class path for you, and it will give you a project structure asking you to put your Java code here, test cases here, so that it will automate the entire build process and deployment processes. So now what I will do, if I type this command, it will give you a hell lot of things as the templates. There are around 700 templates I think in Maven. So to explain you that, I will try to write these things into a file. Maven archetype :generate is the command, but I am just writing them into a text file so that I can show you what are the various types archetypes that we have. So when I run MVN archetype, it just checks to see So in the Maven practice, it is generating the archetypes actually. So it will take a while. It will generate the required source structure for you. You can see here, these are all archetypes. I have just written them to a file. You can see so many archetypes here. I'll show you a couple of interesting things. There are around 700 archetypes. These are all contributed by companies saying, if I want to have a sample Maven project, this is the archetype that you can choose. If you give 251, it will generate a sample Maven project, and it will also give you corresponding source structure. It will also give you a pom.xml so that you can automatically build that project as well. So what you see here is, if you choose an archetype, it will give you source structure, it will give you the build script. Both it will give you. The screen that you see here is the archetypes that I have written to a file. I have just used a pipe symbol to a greater than symbol, and I just put them onto my text file. Here you can see various archetype number and corresponding template. I will point you to a couple of interesting things. If you see the number 251, you will see an archetype which contains a sample Maven project. So now you can see here line 251, you can see that the archetype number is 251, And here it says clearly an archetype which contains a sample Maven project. What does this mean? This means that if you ask Maven to generate an archetype 251, Maven generates a source code structure which suits a sample Maven project. Along with source code structure, it gives you a form which you can use to build that project. So everything will be prepared for you. That is the advantage of your archetypes. Similarly, if I go to little below, let me check, because these numbers keep changing. As more people contribute, it will be alphabetical order. So as more people contribute, the numbers will be changed. That's one pain with these archetypes. So I will just check for any var file. Okay. See, if you join a company and if they say, hey guys, I want you to create a Maven project for me for my source code, you will say, what they say to you is, it's a web application, Java based web application based on Java 6 version. It's a web application. The artifact of that web application is EAR file, and automatically after the EAR file is built, I want to be deployed onto JBoss. See the beautiful archetype here. So if you read this, what it will tell you is, it's an archetype that generates a Java EE6, Java Enterprise 6 web app project for JBoss 7, which means the output of this will be an EAR file with automatic plugin for deploying onto JBoss as well. That is the kind of flexibility that Maven can give you. Maven can generate a source structure along with a form, and if you just say Maven package, it will run the project, create EAR file. If JBoss is installed for you, it will install the var file automatically into JBoss as well. Okay, that is why you can see below. If it is not EAR file, it's a var file. Let's assume. So you can use this number 540, where you can see JBoss Java 6 web app. Maybe it's a var file. If you are using, say, Weblogic, some number BEA. Okay, this is not there anyways. So using these archetypes, using these numbers, you can actually pick up a particular project model which will actually work in your environment. So let's go with a simple Maven project now. So what I will do now is, I will say MVN archetype generate. When I say this, Maven will download required things for running archetype command. Keep it in your local cache. So where does this your local cache reside? Local cache reside in your users, in your particular user. You will have a PC1 is my user. You will have a .m2 folder. In this .m2 folder, there will be a repository. In this repository, whatever Maven is downloading from internet will be stored in your local cache. Here I want you to understand one thing. Maven works with repositories. There are three types of repositories broadly in Maven. First is public repository. If you are downloading any JUnit, if you are downloading any JBoss, anything, any jars, any dependent jars, you will generally download from public repository. Public repositories are like Artifactory, Nexus. There are a couple of Ibiblo. So there are a couple of public repositories from which Maven downloads the dependencies. For example, here JUnit.jar it requires for compiling or running your test cases. So it downloads the JUnit.jar from the public repository. So first entity in your Maven repository structure will be public repository. Storage. All the open source or third party jars available which are required for any of the Maven project will be stored there. So when you say Maven first time, when you are running Maven compile or Maven compilation first time, whatever dependencies are required for your project, it will go and fetch from the public repository. And where does it place? It will place in your .m2 folder. It will place all the things, it will download and it will place in a very convenient manner. And it automatically sets up the class path as well. So second thing that you see here is your cache. This for me is a local cache. In every developer system there will be a local cache. This is second model of storage. From public repository it will fetch and it will store in your local cache. Second time onwards it doesn't go to internet. It will look at your internal cache and fetch it from there. But in case if a new dependency is added and that is not there in your internal cache, again it will go to public repository and download. And after it does, it will build a WAR file or AR file or a jar file based on your project. So once it builds this, where will it put? It can put in your M2 folder. But if it puts in your local M2 folder, it is not available for your other teams, right? So do you want me to put in public repository? I don't want to put my code in the public repository because others will be hacking my code. For that, you will have a third form of storage where internal repository or we call remote repository. So remote repository is generally used for storing your team artifacts. So you have public repository where you have third party artifacts. You have local cache where all the downloaded things from internet will be stored. Even your artifacts also can be stored in that local cache. And third form is remote repository where after you build your team artifacts, for sharing with other team members, you will store in a remote repository. That you don't put in your cache because others can't access it. That you don't put in public repository because even outsiders can access it. So you will have three layers of storage. One public storage, one your company repository where you put all your team's artifacts and your local internal cache which is used as first point of reference when accessing any dependencies. Is this okay? Good. Now let me say Maven archetype :generate. So it starts scanning up, it downloads. If for running archetype command, if I need any dependencies, it will download from internet, sets it up in my local M2 repository. Now it is giving me the list of archetypes available. It is also choosing me a default number 251, which we have seen in our file that 251 is a standard Maven project. So it's an archetype which contains a sample Maven project. Good, that's what we want. Click on enter. It is asking me some version. It's also choosing me a number on its own. Let me go with what number it has chosen. Default, yeah, here there are three things: group ID, artifact ID, version. For any element, any jar or any var, anything in Maven is recognized by three coordinates: group ID, artifact ID, version. Group ID, understand it as company's name. Artifact ID, name of your jar file or var file, whatever it is. Version will be your latest version which is released. For example, if you see in your local M2 cache, lot of third party things, right? You can always see DOM4j is the company which is releasing it. Okay. Group ID, any element in Maven, any binary in Maven is accessed by three coordinates. 1, group ID, 2, artifact ID, 3, version. Okay, if you see here, JUnit is the group ID, JUnit is the artifact ID, 4.8.2 is the version, and inside that you will have the artifacts. Actual jar will be inside this. That is how any jar file or any var file in Maven will be referred as. It will be referred with class vaults is the group ID. Class worlds is the artifact ID. 1.1 is the version. Inside that you will have the binaries. Similarly, commons IO is the group ID. Commons IO is the artifact ID. 1.4 is the version. In that you will have the actual jar file available. So Maven recognizes any jar file by so Maven recognizes So the summary that I want you to understand is, in Maven, any jar or any var, whether you are generating it or whether you are downloading from third party, will be recognized by 3 coordinates. 1 is group ID, 2 is artifact ID, 3 is version ID. Okay. Generally group ID is also, you put it as package structure. Suppose you are in ABC company, right? So your group ID will be com.abc. Your package structure will be your group ID in general. There is no rule as well. You can choose anything as your group ID, artifact ID. So here let me choose group ID as sample app. Okay. I can choose this as well as my group ID. Okay. Now artifact ID. Let me choose same sample as my sample app is my artifact ID. Okay. And version 1.0 snapshot. Yeah, let me make this 1.0 snapshot. So define package. I can say sample app is my package also. Okay. Do you confirm these properties? Yes. Enter. So now build success. So what do I mean by build success here? Means Maven has succeeded in building a project model for 251 archetype. So where can I see it? Let me go to my Maven practice folder. You will see sample app here created. In that you will see here source and pom.xml created. So source here, if you see, there will be, it's a standard structure which Maven has given me. It will ask me now, see if I have some Java code, put it here. By default, it has created some structure. Okay. Here I can replace the sample Java file with any other Java code that I have. It is a template. It is asking me, it has put some Java file just for me to complete a demo. In reality, when you generate archetype, you will replace this Java code with your Java code. Similarly, here you will have the test. So here it has given a sample just test for me to as a demonstration. You can actually replace this test with your own test files. But the structure is important for Maven. Source, main, test. This is important for Maven. Because based on this structure only, it can automatically generate jars. It can automatically does deployments. So Maven, when Maven is generating a structure for you, if you restore the, if you retain the structures, it will be much easy. It does not mean again that it is hard fast rule to maintain the structures. You can always tweak them. But at this point, let's stick to what structure it has generated. Right. And more importantly, it has also generated pom.xml for us. Pom.xml is very important in the context. It contains all information related to the build of the project. Here it knows what is the group ID, artifact ID, version which we have given. It is also having a name, sample app. If there are any properties, which you will be giving some properties in Ant. If you want to give any properties in Ant, like in Ant, you can give them under the properties section here. If your project has any dependencies, they will be here. They will be listed here. Okay. So this is all generated. So later I will show you how can we extend this POM, how can we add new dependencies, all that I will show you. So now at this point what we have seen is an archetype generated, a pom.xml generated, a source structure available, some Java files are also available there. So now we have to build this project. So here there are the build cycle in Maven has lot of phases. Now let me go to that discussion now. So this is my this is where I have prepared my own notes for Maven installation, what are Maven things. So sample POM we have seen. Now we will look at build cycle now. A Maven build cycle has a lot of phases. In fact, it has 23 phases. But we don't require to think about all these 23 phases at every time we are using. I will highlight the important phases. When you want to, so far what we have now is a project we have, a pom.xml we have. So what next? Build it, understand the build process, internals, and then build it and see the artifact generated, and then let's put it into our internal repository as well. Okay. So here you can see there is a phase. Build cycle in Maven runs as a set of phases. These phases are cumulative. For example, compile. Compile phase actually is about compiling your source code. So when you say compile, these are all the actual 23 phases. Just let me show you. First is validate phase. Validate phase will check your POM is consistent. Is POM containing correct configuration? So it will kind of validate the structures and it will check if the POM is consistent. So the first phase in Maven build cycle is validate. Validate will check if the pom.xml is correct, project structures are maintained, is project configuration correct. So all these things Maven will validate. So after validate, the important stage is compile. Compile will compile your source code and generate the class files. You know what is compilation. If you have .java files as your source, .class files will be your compilation. Similarly, the important thing, next thing is test. Test actually will run unit tests pointing to your class files. So what is a unit test basically? Why do you require unit tests? Let's spend a minute actually here. So you are implementing a Java code for testing a prime number functionality. So you write some logic. You divide with 2, divide with 3, based on reminder that you get, you will conclude with some logic what is a prime number. And now you want to test it. How do you test? Today you will give 2, 3 some numbers and see if it is working. After 3 days you make some change. So again you want to test all the combinations. After a few days you make a change. Again you want to test all the combinations. So instead of doing those things manually, you prepare unit test cases. A unit test is nothing but passing a expected input to a functionality and asserting it if the output of the logic you have written is matching the expected output. For example, for the prime number function, if you are giving 2 as the input, your output should be your function, your logic should return me it's a prime number. At the same time, you know the value also that it should come as a prime number. So you will compare. You know the expected answer and you will actually check what is the actual output of your function. And you compare both of them. If both of them are matching, your test will pass. If both of them are not matching, your test will fail. So unit test is nothing but testing a method, testing a functionality with a given input, with a known input, and matching the actual result with the expected result. Then once the test cases are run, the next thing I will do is package. Package means take the compiled code and package in a distributable format. A jar file, a var file or EAR file. Typically they are the artifacts of any Java J2EE project. And then you have install. What does install do? Install will put the package into my local cache. And then you have deploy. What deploy does is, if I have any company repository, remote repository, it will put the artifact in the package in the remote repository. Here I can deploy in my remote repository or public repository. Deploy means send it outside. Don't confuse with deploy as your deployment any Weblogic or any application server. Install and deploy in Maven have no relation to deploying in application servers. Install will put the jar file with group ID, artifact ID with that structure in your .m2 folder. Deploy will deposit your package in your remote repository, I mean in your company repository, or it will put in your public repository based on whatever you give as your repository code. So now another point to note down here is that all these phases are cumulative. Means if I say compile, it will take care about all the previous phases. If I say test, it will take care about all the previous phases. If I say package, it will take care about all the phases so far. Okay, these phases are cumulative. Now let me run these phases. Maven compile. Now I am running Maven compile. So it will validate, it will do all the steps before compile. Okay. This is because I have to compile from my project. I am not in my actual project. So I am just going into my project because source and pom.xml are here. Earlier it failed saying pom.xml did not exist. Okay. MVN compile. So now it will compile my sample app. For compilation, whatever Java related things it requires, any plugins for compilation, it will download. Okay, it compiled. You can see that in my sample app. Now I have a target folder created where I have my class files created for my Java code. One step done. Next, let me say MVN test. So now again you can see it will download whatever things are required for testing. It is again compiling and then it is running the test cases. It has completed. Now when it runs the test cases, it will generate some reports. We will talk about these reports little later. Surefire reports it will generate, but that's something which we will discuss little later. But what I want you to understand is test actually did compilation as well. Since there is nothing new to compile, it did not do any compilation extra. But if I delete this target folder and if I say Maven test, you can see that Maven test will actually do the compilation part, compiling one source file. Okay. And then Maven will run the unit tests to give me feedback on the changes done. After that, now I want to package it. I will say MVN package. So now it is compiling, it is running test cases and then it is compiling. It has created one jar file. It will be artifact ID - version. That is the structure of any jar file or any var file. Artifact ID - version. Now if you see the target, you will see the jar file that is getting created. So what we have seen in this is Maven compile, MVN test, Maven package. Now we will do Maven install. So it is compiling, it is running test cases, creating the jar file, and it's downloading for installing it. If it requires some dependencies, it will install. Now you can see installing sample app 1.0.jar into c:users.m to repository. It created the structure beautifully. You can see here. Group ID sample app, artifact ID sample app, version 1.0 snapshot. In that it has put my jar file. So that is how you can see the sample app. My jar also has entered into the local cache. Sample app, group ID, artifact ID, version. In that it will put the POM file and jar file, both. Deploy will take a while. I want you to explain more about repository structure to talk about deploy. But these are some of the build phases that you will be coming across in your day-to-day activities. So let us do now for one more project. Okay. So I will say again mvn archetype generate. You can very quickly follow. It will be a quick repetition so that from tomorrow I will explain you about how do you add some dependencies. If a new code is added, if you want to add a dependency to POM, how do you do that? There's an important concept in Maven called plugins. So we will explore those things, but this will serve as a good introduction to that. So let me give a new number 540. Okay. So 7.0. It's asking me to choose 3. I will choose it. So now it's downloading things related to JBoss. Yeah, you can give this on directly. You can give the number in one single command. You can give all this information also. I'll show that command probably next class. I'll prepare that command and show it to you. Group ID. Let me give com.jboss sample. JBoss app. Okay. Or JBoss demo. Okay. Training app. Let me name artifact ID is some training app. Version 1.0 snapshot, that is fine for me. Package com.jboss demo is fine for me. Yeah, these are the things which I want. Click yes. So there is some problem. I think that is because the training app folder is already there. Okay, let me just do it again, guys. The build success. Now let's go to the practice folder that we have, and here you can see JBoss app created. Now you can see a lot of things being created here. You can see now the source structure. You can see some web app. Okay, you can see some Java code because it's a web application. When you say web application, you will have some JSP files, you will have some HTML files, you will have some Java code, you will have a lot of things in a web application. So even for that, very conveniently it has created whatever are required. It has created where to put HTML files, CSS files, everything. It has set up a proper structure for you for maintaining a web app. Similarly, it has written some test cases also for you, where you can run the test cases as well. Okay. Now if you open the pom.xml, it is little bigger. So again you have group ID, artifact ID, package. So you have dependencies here. The dependencies is on JBoss. A new dependency is here. It has lot of other things as well. These are all Java related. For this web application, whatever third party things are required, this is a Hibernate Spring involving web application. So for running Hibernate and Spring in your system, whatever third party things are required, it will automatically download. That's the beauty. You don't need to set up Spring, you don't need to set up Hibernate in your systems. Maven will take care about things. Here you have another important feature, plugins. I will introduce this to you today, probably spend more time on this in the next class. Plugins are actually actions in one way. What you want to do is you want to compile. Okay, you want to create a var file. So you have var plugin. You want to compile. You have a compiler plugin. Okay. So you want to deploy in JBoss. So you have a deployment plugin. So this plugin deploys your var file into a local JBoss file, local JBoss installation. Okay. So plugins are kind of actions. By default, it does certain actions. By default, it does compilation in the build phase. But if during compilation phase, if you want to pass specific information, like this is a Java 6 project. This project is running on Java 6. Suppose you can have Java 1.5 installed, 1.6 installed, 1.7 installed in your system. But you want this project to be compiled with only 1.6. You mention in your source and target here. If you want your Java to be compiled with 1.7, you only give 1.7 information, 1.7 here. If you don't give this, this is a default compiler plugin. Even if you don't put this plugin, Maven will compile, because compile is a phase which Maven knows. But if you want to compile with some setting changes, those kind of things you can put configuration here. Similarly for var file, by default var is when you say package, var is an expected package. It will generate var automatically. But if you want to add some specific parameters at the time of packaging, that you can add. Maven compile is a known phase. Maven package is a known phase. Maven package will automatically cater for jar file, var file, EAR file. But in spite of that, if you are doing any packaging and you want to pass specific inputs at the time of packaging or at the time of compilation, you can use this. You can put explicit plugins. Something like deployment in JBoss is an action which Maven does not do by default. So if you want that action to happen, you should put that plugin. So you can think plugins are some actions that will happen as part of build process. Some actions are by default, some actions you have to explicitly put. Actions which are default are compile, test, package. These are all default. Install, the default. But if you want some actions to be done during this process, you have to add your own plugins. And if you want default things also done with some customizations, that also you have to explicitly put in the plugins section. So you can understand plugins as some actions that are going to happen at the time of your build process. Now let me, for this, let me go to my JBoss app and let me, say MVN compile. It has done some compilation now. Cool. It's downloading certain things related to JBoss web application build process. Let it download. Now after it downloads, then it will do a compile of things. See, these are all dependencies. If you have to do this with AND, you have to download all these things. You have to set them in the class path. And then you have to do compilation, which is quite a difficult process because we exactly don't know what are the dependencies and what are the versions for a Spring application. But with Maven you only have to tell it, I want a Java web application, Spring based, Hibernate based web application, and it uses JBoss as deployment path. And Maven will take care about downloading everything what it requires, setting up the class path and putting them in your local cache so that next time onwards you don't need to download them. So it's compiling now. So it compiled the 6 source files. Success. Now let's do a Maven package. So it's compiling. Again, since package is a cumulative step which we know, created the var file. Now if you go here, the JBoss app, you have the target, and then you have the JBoss app. You have this JBoss app.var file generated. Now if you want to install this, it's compiling var creation. It's not downloading anymore because it has things in your local cache. So it has installed. Now let's just go to our M2 repository, and then here somewhere my JBoss app will also be there. Com. I started with com. So com JBoss demo. Here you can see JBoss app. Here you can see 1.0 snapshot. Here you can see my var file, beautifully structured. And if I put this in public repository, even you can download it by putting in your pom.xml. Something that we have discussed today about how do you build a Maven project, a var based project also we have seen. We have seen what are the build phases. One last build phase which I want to tell you is MVN clean. Like you have a clean target in Ant. There is a clean build phase in Maven as well. It will delete all the target folder, all the intermediate build files which got created. So in MVN clean, compile, test, package, install, deploy are the major build phases that you would be using in your day-to-day activities when building projects with Maven.